Okay, so we have an Eaves detailed drawing of a lean-to roof. So the main areas, there's quite a bit in this work here, right? But the main areas we have the eaves section, we have the cavity wall, we have the rafter, the joist and the slates and the soffit and fascia and so on in this area. It runs up to this side here, so it's like a little roof that's been built off the side of a house, maybe an extension or a shed or something. It's got a wall plate here that's fixed to the external wall of an existing house. So if you can imagine, this is a cavity wall of an existing house, and this is a lean-to roof that's built off the side of it. The most tricky part of this roof is, of this drawing, is more often than not the slate section. People often struggle with the slates. We've looked at that in a few worksheets, so hopefully we will be able to manage that. Alright, so that's the completed drawing. I've got a blank sheet set up here. Just bear in mind that, as always, I've got a border and title box, nice and neat and tidy. Name, title of the drawing, and your scale. We're going to go with scale of 1:10, and just a nice and neatly presented drawing with your border and title box. Equipment we're going to use, we obviously have a T-square here. We have 2H pencil. I have a HB pencil as well. I'm going to use a HB pencil for the sake of my drawing, just so it's more clear, but I would recommend everyone use a 2H pencil and maybe even a H pencil for your dark work. Obviously a rubber 60-30 set square, 45-degree set square, and a set of pens. So blue, red, green and black are always handy pens to have when you're doing the detailed work of, say, your felt or your DPC or whatever else. Alright, so we'll make a start. Again, I always say to students, sometimes when you look at a drawing like this, it can be very off-putting because you're looking at the whole thing and there's a lot in it, or it looks like there's a lot in it, but if you break it down to one section at a time, it becomes a little bit more manageable. So I always say, generally speaking, with a detailed drawing, try and focus in as if you're the builder. Like, you can't draw the roof and the slates without having built your wall. So I would always say, start off with your wall, build up the wall, then build up your joist and your rafter and your slates, and then build up this section here. So we're going to start down here on the bottom left. It's an A3 page, and it fits fairly well on the page, but just make sure that you're smart about whereabouts on the page you're going to start. You know, obviously down towards the bottom left of the page, but you leave yourself a bit of space over here for the soffit and fascia to come out. So I'm going to start just in a rough section, roughly over there. So you can see there's the bottom left of my page. In a bit, you know, come in approximately 80 or 90 millimeters to make sure you have plenty of room. I'll zoom into that section there where we want to start, and the work will be a bit more clear. Okay, so cavity wall we're going to start with. Everything we draw is light at first, as we all know. We'll draw everything light. I'm going to draw with a bit of depth because of the video. I'm using my HB pencil. Cavity wall, there's the outside line of my external leaf, so 100 millimeters for your external block, 150 millimeters for your cavity, and 100 millimeters for your internal block. Lightly draw those lines. Again, I'm going to draw a little bit darker for the sake of your the video. Again, how far up do I go? Doesn't matter just yet. Alright, I'll just rub out that line that I just drew. That was a little guideline that I used. I'm going to go roughly, let's pick a point up there, and that's going to be the top section of my wall. Now again, this is all, I must stress, this is all light work because there's parts of this that won't exist. My internal leaf, I'm going to just work down a couple of blocks. I like to draw in some blocks. A block is 225 millimeters. Scale that down. Scale that down. We've got 22.5. So, you know, you're going to get away with 22 and a bit. Don't overthink that half. 2 blocks is fine. Okay, now my internal leaf, I'm going to put a bit darken that down small because that is confirmed. I want to just speak a little bit about the external leaf with an Eaves detail roof. I'll take my solution out as well. There's a bit of variation on what you can do with the external leaf. Some drawings you'll see the external leaf goes right to the top, the same height as the internal leaf, and the rafter just comes down through it. In that sort of a scenario, the carpenter would have to knock out a bit of the block so the rafter goes down through it. And that's fine, that's acceptable. More often than not though, what you would see is the external leaf is built, so there's the top of the internal leaf. The external leaf is built a block lower, but just on top of that they use a smaller block, they call a soap block or a soap bar. It's basically just a smaller size block to build that up a small bit, and just the rafter will generally fit down through that. Now as I said, it is acceptable to build your block up this height, but it's just good habit maybe to go a block lower and just put a small block on top of it so that the rafter does not have to be cut through that block there. Alright, so in this scenario I'd be rubbing this out. As I said, we do it lightly. I'd be rubbing that out, that top block, and I'll put a small soap block on top of that, basically a smaller block, to make room for the rafter to sit down rather than the carpenter having to knock out pieces of the wall so the rafter will pass through it. The reality is, in an exam situation, either method is acceptable. Okay, so there's the external leaf and there's the internal leaf. Rubber to tidy up that little section there. Now, inside that cavity wall, we're obviously going to have our rigid insulation. On top of that block wall though, we have our cavity closer, which we have looked at before. So I'm going to draw a line across there. It's that little plastic member. We'll make it 50 millimeters, they can vary in size. It's that rigid solid plastic member that is wrapped in rigid insulation as well, and that just closes off the cavity so that moisture, water, dirt, whatever else can't fall down into the cavity, or it doesn't form any sort of a thermal bridge in the detail area. So again, our plastic member, our cavity closer going across there. 100 millimeters of insulation needs to go on the internal side of that cavity wall, and the symbol for that needs to be done in. Now, once we get that done, we can move forward. Again, I'd always say let's do this, fairly light at the start until you're very confident that whatever piece you're drawing is going to stay and doesn't need to be rubbed out. You can start go over heavily then. On top of the internal block we have a wall plate. A wall plate is 100 millimeters wide and 80 millimeters high. Okay, wall plate, for anyone who forgets, is basically a length of wood which is fixed to the block wall, to the top of the internal block, and it runs around the perimeter of the building. Alright, right there now we're looking in at the end of a piece of wood. When you're looking in at the end of a piece of wood, X is what helps to represent that. So that wall plate is basically nailed to the top of the wall. Straps can be used to hold it into place as well, and that wall plate allows the carpenter to fix their rafters in there using the bird mount piece of work, which we spoke about before as well. Right, once the wall has been built, what rests on top of the wall is a joist. Okay, so a light line. How far across here have I gone? Doesn't matter just yet. The joist sometimes can be 225, but often they can be 150 millimeters as well. I'm just marking the position of my joint there now. That's a light line. There's two light lines that I've drawn there now. The next position I'm going to draw in is the rafter. Alright, what angle is the rafter? That depends on the architect, depends on the design. For the sake of this drawing, I'm going to draw my rafter at 30 degrees using my 60-30 set square. The rafter has to cut through the wall plate. Alright, roughly a third of the rafter has to sit in there. That's the bird mouth joint. Sometimes I see students and they just rest the rafter on there. That's incorrect. The rafter has to pass through here. So lightly we'll draw the rafter in first of all. Alright, and I'm going to, rafter is 150 millimeters wide, by the way, so I'm going to rest 0 on that line, go out 150 millimeters, and I'm going to draw that much. Alright, so we have the position of a joist, we have the position of the rafter. Now, next thing that we will look at will be the soffit and fascia area. So I might just get that drawing in there again. So we're going to look at the fascia, which is the board on the front, the soffit there, and we'll try and get those positions in correctly. How far out here does the fascia go, or how far down does the soffit go? Again, depends on the design of the building, depends on the architect. There is room for variation. Generally speaking, I would just go down to the, maybe roughly to that block there, and start by drawing in my fascia or my soffit. So I'll go to that first joint there. You could go further if you wanted, but roughly that position there, and I'm going to draw a line straight out there. And I'm going to draw a line straight up here. Again, this is all light work. And what I've got there now is the position of my fascia and soffit. I can rub out those lines. I'll rub out those few bits on the joist just to make things come a bit more clear. And I'm going to start working on my fascia and soffit. A soffit generally is 12 millimeters, so you know, go about 1.5 millimeters. That's done lightly. The fascia is usually 20 millimeters, so about 2 millimeters for that. Again, I'm still working lightly with everything. Put a little bit there of the rafter. Your fascia often just runs a little bit below the soffit sometimes. Detailed in our book have it that way, so go maybe 5 or so millimeters below if you like. There is room for variation on this section, depending on the manufacturer, depending on the design. There's the soffit drawn in. Alright. I'm going to put in a 100mm vent in there as well. We've seen from our notes that the vents can vary in shape and size and type. If you just put simply 2 lines there, that will represent a vent. Okay, now I will just extend that up here a little bit, and we're now going to go, I'm extending that up lightly. The fascia goes up a little bit past the rafter. How far past is going to be defined by our tilting fillet and our battens. Alright, so this is the section where it tends to get quite tricky and difficult. So as I said, this is the part where it gets tricky and difficult. When it comes to drawing in the slates, it can get a bit messy. There has to be an overlap with our slates. I'm just doing a small bit there. There has to be an overlap with our slates, alright? And the slates are very thin in reality. And when you're drawing slates with your pencil, it's just a line, alright? So and that's where it can get a bit smudged and so on, and frustrating to draw. There's always an overlap between slates, but at the very, very front, there's actually three courses of slates on top of each other. Roughly a third of a slate is put in place first on that first batten. Roughly half of a slate is put in place on top of that, and then on the third batten, a full slate goes in. So you've actually 3 slates on top of each other there, and from here back, there's just 2 slates overlapping each other, full slates all the way up. So you've roughly third, roughly half, a full, and then fulls are just constantly overlapping each other all the way up. Sizes of slates can vary. In your Get Constructed book, it has a slate at 600. I usually go with the slate of, in your Get Constructed book, the slates are 700. I usually go with slates of 600 millimeters. And the Essential Construction Bloody Journal has some good measurements on this that are worth following. The slates have to go a little bit out over the fascia board as well. So if you go 50 millimeters over the fascia board and measure back 250 for your first batten, and then from there measure back 350 for your second batten, and then from there on it's just 250, 250, 250 for all your battens. That, by the way, is 250 to the center of the first batten and 350 to the center of the second batten. 250 centers. Okay, so we're going to go with those measurements. As I said, there is variation on that, but I suppose it's just good to learn one way of doing it, as opposed to kind of confusing yourself all the time with different ways. So before we do anything, we're going to put into position the battens. The battens, right, size wise are 50 millimeters by 25 millimeters. All right, so what I'm going to do is I'm actually going to extend that line out a little bit further, and I am going to measure. I'm going to go out 50 millimeters past that line. So from this point here, the front of the rafter, I'm going to go out 50, and I'm going to start all my measurements from there. So that point there is 50 millimeters past. That works out 5 mil when we scale it down, and that's where I want all my slates to go past. Bear in mind, we're going to rub this out shortly. Alright, so from there I'm going to measure 250 and 350. That position gives me the center of my first batten. That position gives me the center of my second batten. These battens are 50 millimeters wide, so I'm going to go 2.5 mil that way and 2.5 mil that way. Same here, 2.5 mil that way and 2.5 mil that way. This is the main tricky part of it. Lightly, I'm going to go out perpendicular to the rafter. The rafter is at 30 degrees, so my set square, you can see, is at 60 degrees. Those battens are 25 millimeters in thickness, so we're going to go up here 2.5 mil. Again, 30 degrees is what my rafter is at, so I can just extend the line up along there. I'm actually going to go lightly all the way up along, because I'm going to need that line for the rest of my battens. This is all light work, as I said. I'll zoom in there. I might just talk you through that bit again. Down past the fascia, so along the bottom of the rafter, I've measured out 5 mil, and from there to there I've went 250 and drawn my batten around it. From here to here I've went 350 and drawn my batten around it. The batten is 50 that way and 25 that way. I'm just going to go in heavily around those two battens and maybe rub out any of the waste around those. This kind of work does take practice. This kind of work can be frustrating. Just takes patience. And what we're looking at there, by the way, I might rub out those dots. What we're looking at here is the ends of the battens, the ends of a piece of wood. So as we did with the wall plate, with the ends of a piece of wood, we are just marking them by joining the diagonals. That's those two battens. Okay, now first two battens, I'm going to do one or two more battens just for the sake of having those in place so I can do my first couple of courses of slates. Basically then from that position on, 250, each batten is just 250 mil centers all the way up. Now you could measure from the center 250 and then go out either side, but you could also just measure from the front of it and go up 250 and that gives you the front. That's the same thing. So I'm going to put my set square there, set up on this and go 250 and then measure across my 50. There's the first batten or another batten in place. I'll do two more battens just for the sake of our learning on those. Again, from the front of that batten, 0 is there, I'll measure up 250, and then as we know the battens are 50 mil thick. batten 0 is here. I'll measure up 250, then add 50 to that. Again, everything is drawn lightly first, go heavily afterwards. I can rub out that light line that I drew there kind of to guide me on that. My rafter and all is still done lightly. This is all still done lightly. It needs a lot of tidying up there, but for the moment we'll go with that. Now, at this point, I'm going quite slow on this part because it is tricky, right? We have a tilting fillet, so at the front the fascia runs up a little bit past the rafter, and there's a little tilting fillet, a piece of wood that brings you up level with that, so it can guide the rainwater away or any moisture that there is away. What I'm going to do is, how far up does the fascia go? I'm going to extend the line across the top of the batten, parallel with the rafter, and that will give me the front corner of the fascia. So basically what I do is, I might zoom in here now, I am going to extend a line along here lightly. I go a bit heavier for the sake of the video on that. Where that line extends, hits the front of the fascia, that's going to give me the front of my fascia. Now again, all this is getting a bit messy, so I'm going to get my rubber. I can rub out all this light work now, and that gives me the front position of my fascia. Alright, so basically what I did was I extended here parallel with the rafter, and where that hits the front, that gives me the front of my fascia. Okay, fascia board is in place. Now, slates. Slates that we are going to use on our drawings are 600 millimeters long. It can vary in size, but the ones we're going to use are 600 millimeters long. Slates are nailed to the center of each batten. Slates will overlap 3 times at the front, but they'll just overlap twice on top of each other all the way, the rest of the way up. Okay, slates need to go 50 millimeters out past the fascia to make sure the rainwater goes away off the house and into the gutter. The first slate. We are going to go take a line again, just mark a little position there 50 millimeters out past the fascia, and we're going to put a slate from the center of the batten out over the rafter, out over the fascia, 250 millimeters. A nice, at best, a thick line. There's my first slate in position. Alright, now what can happen here is I go and draw my next slate and it becomes one big smudge here. Alright, so for the sake of the drawing, by the way, my next slate in size is going to be 350. I'm going to go to the center of that with my 350, and I'm going to draw a line and just have the tiniest of gap in between those. And the reality is there's a tiny gap between those, just to try and avoid having that smudge. The reality is they're going to sit on top of each other, but just the tiniest of gap to show that there's 2 slates. And then my last slate is 600 mil, so I'm going to go back to this batten here, 600 millimeters, and I'm going to bring my next slate down along there. As we said, at best, a thick line. What we have down here is 3 slates on top of each other, 3 slates overlapping to help with the rain. The tilting fillet, by the way, you can just draw in from the top of the fascia a random angled piece in there, and that's that. Now, from there then, for the rest of the rafters, the rest of the slates, they're full slates, 600 millimeters. So all I have to do now is go to the next batten, center of the next batten, mark off my 600 millimeters, and practice drawing the lines there. That slate, I'll go to the next batten, 600 millimeters, along there as well. Alright, and you can see there's a tiniest of gap between those just to represent each individual slate. The reality is they're resting on top of each other and there's actually not a gap on that. Now you can work your way all the way up. Usually in an exam situation they'll only ask you to draw 3 or 4 courses of slates. I'm going to stop there with the slate at the moment. I might finish off some more afterwards. One more thing to draw up here, we're going to draw a gutter. Gutters vary in shape and size, so don't overthink the size. Some are round, some are square. Let's not overthink it. I'm just going to make it 100 millimeters, kind of a square size gutter, shape gutter. Resting in. Okay. Put a little angle maybe on it. Often gutters have that. And that's the position of the gutter. Okay, so we have our cavity wall, our wall plate, our rafter, our joist, soffit, fascia, gutter, tilting fillet, battens, and the slates in place. There's still a lot of work to be done on that. You can see my rafter and my joist are still drawn lightly also. We'll fill those in shortly afterwards. Another thing maybe that we'll draw in before we go over to the other side of the wall is the eaves ventilator. Air, like mineral wool insulation is going to come across here, and ventilation, air must get up from the soffit up into the roof. There must be a flow of air able to get up into this section of the roof. If not, these wooden members are going to go going to rot, and it'll compromise the structure of the roof. Sometimes what can happen is this wool insulation will go all the way across, it'll get stuffed in here and it'll block that air flow getting up. So an eaves ventilator, like we've looked at before in our notes, needs to be put in this position to allow airflow through it. Eaves ventilators generally 700 millimeters in length. Position wise, just make sure that it runs from somewhere from around here up into the roof section. So I'm going to put my eaves ventilator 700 millimeters there, and just approximately 30 millimeters. So 3 millimeters from my eaves ventilator. Just going to remove that section of the joist because it won't be seen. And that is my eaves ventilator. So air will be able to flow up through there and up into the roof. Now, we'll leave, there's a little bit more work to add. We felt to add, we have insulation and things to add, but we're going to just go over and continue to work on the structure of this building. And we're going to draw the external cavity wall of the original house. Alright. Now, to draw that, unless specified how far across here to come, you can just pick a position yourself. So again, things like that you don't need to overthink unless you're told. I'm going to just pick a position about there, and I'm going to start drawing the cavity wall of the actual house in position. So as I said, unless you're specified how far across to come, just pick your own position within reason. Make sure you can fit everything in and so on as well. That's I will just draw a light line here now. I might just zoom in on the work that I'm doing here. And I'm going to draw my measurements for my cavity wall. 100 mil external block, 150 for the cavity, and 100 mil for the internal block. Draw those lines. Those lines are here to stay, so you can draw those in heavily from the start. I rub out that guideline there now. That was done lightly. And now I also can see how far up my rafter is going. So if you want, you can do all the heavy work on your rafter as well. joist. Okay. As I said, insulation I failed to add afterwards. Where this joist meets that wall, it's fixed with a wall plate and some joist hangers. So there's a wall plate nailed to that wall there, or bolted to that wall, 50 millimeters thick, 100 millimeters, 150 millimeters wide or long, and that there is the end of a piece of wood, right, which is nailed to that wall, and the joist hangers would be used in this situation to hang that joist onto that wall plate. Joist hangers we've looked at pictures of before. Now the same sort of a situation up here for the rafter. We're going to put a bigger wall plate into position, 225 millimeter wall plate, so 50 millimeters thick. And that goes out across there. That part of the rafter actually gone now. 225, so a bigger wall plate is used in this situation. Again, that wall plate is bolted to the wall. Your rafter then is cut at the correct angle and nailed to that wall plate by the carpentry team. Okay. Now just getting back to the external wall, we need to draw on some blocks and some insulation on that external wall. So that's the inside of the actual house. So the insulation needs to be on the internal wall of this house. 100 millimeters for insulation, and that insulation again is represented by the following symbol. Now look, it can take a long time. Sometimes you can spend forever doing this symbol work. What I would say is, in an exam situation, if there's a big long section of insulation to draw the symbol in, do a bit of it. Alright, I'm going to just do a little bit of it here now to represent the insulation. Don't spend forever on it. There are some more important things to be doing, so I would say about that much. I'm going to go into this bit section. I'm working swiftly enough on this as well. Do a bit of it, as I said, and come back to it. If you have time at the end, say you're doing an exam and you're finished doing the question and there's 5 or 10 minutes left, that's when you go back and finish off that insulation. But at this moment in time in the exam, there are more important things to be working on for getting your marks. So about that much insulation, and we will come back to it if we can. Okay, some blocks on that. I'm going to pick a random enough point, maybe it's go a little bit above the rafter, that can vary. I'm going to draw my first block, and I'll draw 2 or 3 blocks up above it. 225, that works out with 22 and a bit, or 22 and a half if you're being precise. I'd say go another 1 more block above it. And I'm going to work some blocks all the way down as well, and mark the positions of the wall. Alright, so those blocks, we can draw them in now in their positions. and that's that external wall done. Now there's a little bit of detailing that needs to be done in this section to make sure that roof is waterproof. There's often problematic area here if it's not done correctly. There's DPC, there's lead flashing, and there's felt and stuff to be done. We'll put the roofing felt into place first. So from our notes classes, we know there's a felt before the battens are nailed to the rafters. There's a blue, often a blue felt, roofing felt fixed all the way down there. That's represented by, we'll represent that with a blue pen. Basically a blue pen line that runs all the way down the rafter. Make sure that pen is nice and clear to see. It will come in here, it'll run up over that tilting fillet and just hang down a small bit down over into the gutter. Okay, so basically blue line, actually that blue line needs to run just a small little bit up the wall as well. So that felt will wrap up the wall a little bit there as well, so it'll go down all the way down the rafter and up over there, that felt. Alright, lead flashing. So we've seen some pictures of lead flashing. Lead flashing is built, I'm going to zoom into this section up here now. Lead flashing is built into the wall, into a joint in the wall. You could go to that joint, you could go to one above, whichever you prefer. I think in this case I'm just going to go up to the second joint. So wherever, like, you know, a reasonable one of these two joints in the blocks, I'm going to use red pen. Lead flashing. It's built in there and it goes down over the front of the felt. So that lead flashing helps for the waterproof, so it comes down over there. So you've got the felt coming up underneath there, the lead flashing coming down over there, and that's plastered over as well. That really can't be seen. You could often see a bit of lead flashing there, but this whole part of it is plastered over as well. Alright, DPC, kind of like above the windows and so on, there's vertical a little bit more DPC just to try and avoid any rising damp, maybe getting in here and rising up. The DPC will rest in this joint as well, but it will, there's DPC there, and it's that wider DPC that's going to go up through the insulation, through the cavity, and up along there as well, just to stop any moisture getting through here and trying to kind of work its way up through the wall or whatever else. DPC runs across that way, so there's a bit of detailing work needed. Got the felt, the lead flashing, and the DPC. Obviously the slates need to be drawn all the way up as well. As I said, in an exam situation it can often be just asked for 3 or 4 courses, but look, if you're asked to do the rest of the slates, you just keep working your battens all the way back up to there, and at the very end you might only need half a batten as well just to finish it off also. Alright, insulation. Okay, so we'll do a bit more work on the insulation. So you've got that mineral wool insulation between every joist, so we'll get the symboling in for that as well, because it's important to get this right. So we'll work away. Be neat with this. Now, this mineral wool insulation needs to be stuffed down through there, and again, it's not going to block off that section. The Eaves ventilator is going to prevent it from blocking the ventilation, but it does need to be put down to there as well. Alright, so again, air can still come up here and up into the roof section also. Oftentimes nowadays, highly insulated houses, there'll be a second layer of that insulation. I'm just going to mark a little 150, the insulation, to keep it the same size, a light line there, and we'll do a second layer. So often in exams you could be asked to make sure that the roof is highly insulated. 2 layers of mineral wool insulation will ensure that it's highly insulated. Make sure now that's not blocking off the Eaves ventilator either. I might just go over here now. Again, you're kind of coming, well, you're coming to the end of the question. We've got labels to add, but you could at this point maybe add a bit more work on that insulation there. But I think we will go and start to add our labels. When it comes to labels, I always say, lads, be neat as well with those. Sometimes you see people, they draw lines all over the place, out left, right. It just ruin a drawing, it can look very messy. So I would say just try and be neat with your writing, neat with the arrows coming out. Try and keep them straight where possible and organised as well. So for example, down here I'm going to do all the wall labels. So what I'll do is I'm going to bring a line out from here, a line out here, that can be a start anyway. So what I've got there, we're trying to make sure add size as well. So 100mm internal block, a 100mm cavity insulation, cavity, 100mm external block. We've got our cavity closer, we have our 100 by 80mm wall plate. Okay, we'll just go over here now and we'll draw in soffit. Can vary in size, so I'm just going to write soffit. Fascia. We'll mention the soffit vent, I suppose, as well. Just draw a little line down there. Soffit vent. Gutter. Okay, and then when I'm drawing these roofing members up here, we might just kind of work out perpendicular to it. So I might just go up here, tilting fillet, um, 50 by 25 pattern. 600mm slate in this case, sometimes it can be 700mm. Um, 700mm ventilator. Alright, 150 by 50mm rafter. Roofing felt. There. Alright, we'll get the joist. I might get the joist down here. I always say get as much labels in there as you can, as much as you can remember. The Leaving Cert exam, I think it could be 12 or 13, depends year on year how many labels they're looking for, but I would always say just label as much as you can. We will get this wall plate. 225 by 50 wall plate. We don't need to label all these parts of the wall all over again because we have it done down here, but we will label the lead flashing and the DPC. So I might just bring these lines over to this side. And the DPC. Okay, and we've got quite a lot of labels on our piece then. I might just count those. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 labels. You know, all the more the better, I'd say, with labels. And then if you have time at the end of the exam, I would say just fine tune your work. Add in as much detail as you can with regards to these symbols, and if you really have time, I would even recommend adding some light colour with pencils. It's all just good for presentation of the drawing. A few more on it. Now, as we said before, when it's done, you see all the labels on it and all the symbols and the pen work and whatever else. It can look like a lot when you start off, but if you break it down, all it is a wall, some rafter work and some joists. When you break it down section by section and do bit by bit, it's very manageable. The most difficult part, especially when you're new to it, is the slates and the battens, getting those right. Practice is needed for that. Learning off the measurements for each batten, the varsity batten especially, and for each slate, and again, like anything, with practice it can become easy, and that's pretty much it. So it's an Eaves detail of a lean-to roof with slates on top. Okay, that's it.